Hi, Dr. Anthony Revis here with Watch Me Do It. I am going to work in empirical formula by using combustion analysis data. Okay, so it's empirical formula from combustion analysis. All right, so here we go. Ready? Let's do it. All right, here we have a combustion analysis of a 0.00126 gram sample of polyethylene plastic. Yields 0.00394 grams of carbon dioxide and 0.00161 grams of water. This was all trapped in a device. And the question is, what is the empirical formula of polyethylene? Now, here's what you want to know. As soon as you see the word empirical formula, you want to think moles. And it said empirical formula, therefore, you want to look for the ratio of moles. That's what we're looking for. So let's find those ratio of moles. Now, what we want to look for here is the amount of carbon and hydrogen, because polyethylene is only composed of carbon and hydrogen. That's something we happen to know, and now we share that with you. So polyethylene is only carbon and hydrogen. Therefore, I'm going to look for the moles of carbon and the moles of H. That's what I'm interested in. So I have to find a way to get that. So let's do it. All right, here we go. So let's start with carbon. So what's my source of carbon? My source of carbon is this. That means C. So let's start what we're given in terms of that, and let's work our way to the moles of carbon, okay? So I'm given the grams of this, and I picked it because it has carbon in it. That's my source of carbon. That's grams of carbon dioxide, though. So I want to convert that grams of carbon dioxide to moles of carbon dioxide, because I can play with that once I get to moles. And so then I'm going to want to take those moles of carbon dioxide, CO2, to moles of carbon. Okay, that's what I want to do, and that's what I'm looking for. So that's where I want to go. So the grams of carbon dioxide per mole, that's per every 1 mole, is always per 1 mole here. That's going to be 44.01. I calculate the molar mass of CO2. Molar mass of CO2 is 1 carbon times 12 plus 2 oxygens times 16.00. And you punch these through. Again, there's a decimal, there's a 1 on probably this one here. And so that's what you get. Okay, you get 44.01. Now, watch this. How many moles of carbon are in CO2? Guess what? Look at it. No calculation necessary here. No calculation. I see a 1. I see 1 carbon and 2 oxygen. And I'm sorry, 1 carbon per 1 CO2. Okay, so there's only 1 carbon in CO2. That's the point. Said a little too fancy, didn't I? Okay, and so if you run this through your calculator and you do it the 3 sig figs, you'll get 8.95 times 10 to the minus 5 mole of carbon. So let's do this for what's next? Hydrogen. Okay, the source of hydrogen must be water. There it is. So let's start with water then, and we'll convert water to hydrogen. And anytime I want to do a conversion, we use unit analysis, grams. I'll start this over again, excuse me. We will have 0.00161 grams of water times bar conversion. Grams to moles, we can always do that. Grams must go to moles when you're doing these calculations. They can never do gram to gram. So this is going to be 18.0 or some number like that. Then I want to know moles of water to moles hydrogen. Well, I have 2 hydrogens for every 1 mole water. That I get from just reading it. No math. Just read it. 2 hydrogens in there. Do no math when you do that. No math there. Okay, so here we get 1.79 times 10 to the minus 4 when I do on my calculator, moles of H. Okay, and so When we do that, we take the small one. Oops. Take the small one and divide it by itself. 5 times 10 to the minus 5. And we take the small one here. Smallest value, 8.95 times 10 to the minus 5. And we end up with a ratio 1 to 2 here as well. Okay. And so that gives me the formula of CH2. That's my square in value. And that's how you do empirical formulas. Okay. That's how you do it.